Hello and welcome. Let's solve another interesting question. The question says we should find the area of the shaded region. Trust me, this is interesting. Alright, now if you look at this shape, if you draw a full cycle and you divide it into 4 equal parts, one of the portion there is exactly what is on the board. Is that clear? Alright, now if you look at this shape again, you will notice that we have a bigger cycle and we have a smaller semicircle. Is that clear? Inside of it. So they want us to find the area of this shaded region. So how do we find the area of the shaded region? We are going to find the area of the quarter of the cycle, then find the area of the bigger semicircle, then find the area of the smaller cycle, sum the area of the smaller and the bigger semicircle, then subtract it from what? From the area of this quarter. So that is what we want to do. So let's get started. All right. So the area now. Let's start with the area. The area of the quarter. The area of the quarter of the cycle. Anyhow. All right. Will be equals to. We know the area of a cycle is what? Pi r squared. All right, so we are dividing it into 4 equal parts. So just work on what? One of the portions. So we divide this by what? By 4. All right, so this will be equals to, now if you look at this shape, you will observe that the full shape here from this part to this part is the what? The is just the one portion of the what? Of the cycle. So it means that the full length CE will be equals to what? CD. Is that clear? And if you look at this, CE is given to us to be what? 8 units. Is that clear? So it means the radius of this full quarter is what? 8. So we are going to have this to be what? Pi multiplied by 8 square all over what? 4, which will be equals to what? 64 pi all over what? 4. 64 divided by 4 is 16. Then we have this one as pi. 16 pi unit what? Unit square. All right. Now, the next thing we are going to do is to find the area of this big semicircle. Area of big semicircle. All right. So this will be equals to pi r squared. That is the area of the full cycle. But we said semi will divide by 2. So it's going to be divided by 2. So this will be equals to, now, from this point to this point is the diameter of this big cycle. So if we divide it by 2, we get the radius. All right, and we said CD is the same thing as what? CE. So CD is 8, then half of CD is what? 4. So we are going to have this to be what? Pi multiplied by 4 square all over what? 2. So this will be equals to 16 pi all over what? 2. This will be equals to what? 8 pi then units square. All right. So that is what we are going to have. Now the next thing is to find the area of this smaller semicircle. So we are going to have area of a small semicircle. All right. So the formula remains pi r square all over what? 2. But if you notice this, we don't know the radius of the small semicircle, right? We don't know the radius. But how do we get the radius? All right, this is it. Now, you cannot say that from year to year is what? Is 8. Then from year to year will be 4. No, that is not correct. If you look at our point, now from year to year is different from year to year. You can see that if you divide it by 4, from year to year will be bigger than from year to year. So you cannot say this place is 4, this place is 4. No, it's not correct. Is that clear? All right. So, but how do we analyze this? For us to analyze this, we are going to be joining point A to point B. All right. All right. So now that we have joined the point now because we don't know what our radius is, but we know that from this point to this point is the diameter of this small cycle. So we can say this place is what? R. right? So if this place to this place is radius, definitely this place to this place too is going to be what? Radius. Now, from this point to this point is what? Radius. Definitely from this point to this point is another what? Radius. And we know that from this point to this point is 8, and the radius here is what? 4. So definitely this place too is going to be what? 4. All right. Now that we know that from this place to this place is what? R. And then we know that the full length here is what? 8. So for us to get this point to this point now, I'm going to subtract R from what? 8 to get this point to this point. So it shows that 8 minus R will be from here to here. So the full triangle now, let's bring it out. So that we now perform our analysis on it to get our radius of the small semicircle. All right. We are going to have this. So this is going to be B, C, and what? And D. So BA, not D. All right. So BA is going to be R plus 4. So here is going to be R plus 4. All right. So CA is going to be 4 because the full length here is what? 8. So here is going to be 4. And our CB is going to be 8 minus R. All right. Now, and this place, we have our hypotenuse side there. All right. So for us to get the radius here, we are going to make use of what? Pythagoras theorem. And we know that Pythagoras theorem states that the hypotenuse side is equal to the sum of the two other sides, provided that they are all square. So it shows that R plus 4 all square will be equals to 8 minus R all square plus 4 square. All right, if we expand this, I've already shown us how to expand this using shortcut. We put our square on R, we have R square. R multiplied by 4 multiplied by 2, we are going to have 8R. Put your square on 4, you are going to have 16. Do similar things to this, we are going to have 64. 8 times minus R multiplied by 2, that is minus 16R. Put your square on R, you are going to have R square. Then 4 square is what? 16. So if you look at this, 16 we cancel out 16. R square we cancel out R square. Then we'll be left with what? We'll be left with 8R. We bring out this 16R here, we're going to have 8R plus what? Plus 16R will be equals to what? Will be equals to 64. And 8R plus 16R is what? 24. So we're going to have 24R to be equals to what? 64. If we divide both sides by 24, so 24 will go with 24, then R will be equals to what? 64 all over what? 24. So if we break this down to the final, for the smallest simplification, if you simplify, we are going to have 8 all over what? 3. So 8 over 3 is the radius of that smaller semicircle. So this will going to be in what? In unit. 8 over R unit. All right. So now we can therefore substitute for our R here now, so we can get the area now. So it shows that the area of the small area of small semicircle will be equals to pi multiplied by 8 all over 3 all square all over what? 2. So this will be equals to what? This will be equals to a square is 64. We're going to have 64 pi. 64 pi. Then 3 square is 9. 9 times 2 is what? 18. All right. So that is what we are going to have. All right. So now that we have the area for all this now, so we can therefore find the area of the shaded region. We are going to denote that with what? Capital letter A. So the area of the shaded region is what? A. So this will be equals to what is the area of the quarter? The area of the quarter is 16 pi. So we are going to have 16 pi minus, then the area of the big semicircle is 8 pi. 8 pi minus, then the area of the small semicircle, which is what? 64 pi all over what? All over 18. All right. So A now, which is the area of the shaded region, 16 pi minus 8 pi, that is what? 8 pi. 8 pi minus 64 pi all over what? 18. All right. So if you multiply 18 by 8, you are going to have, so that is going to be what? 144. So we are going to have 144 pi minus 64 pi all over what? 18. So this is going to give us what? This is going to give us 80 pi all over what? 18. So you can leave your answer like this, but you can decide to take it down. So if I divide both sides by 2, I'm going to have this to be equals to 40 pi all over what? 9 units. So in square. So this is the answer to the question that we are asked. I hope this is well simplified. Please don't forget to share this with your colleagues who might be in need of this, and don't forget to subscribe and like, and stay tuned for more interesting content. Thanks.